Solving exponential functions using log. A logarithm is an inverse of an exponential function. There are three types of logarithm. We have general log, common log, and natural log. A natural log can also be called hyperbolic log or Napierian log. And general log is a log that has a base, any base. Log of base 10 is the common log, and log of base e is the natural log. The log of base e is also called ln. ln stands for natural log. Log of any base is log of base 2, log of base 3, log of base 4, and so on. And the log of base 10 can also be written as log, log, or lg. So if you see lg or log, it actually refers to the common default for log of base 10. The reason why we have log of base 10 is because we use 10 numbers, 0 to 9. Hence, we have log of base 10. Log of base 2 will be referring to two numbers, 0 to 1. Log of base 3 will be 0 to 2. And that's how that works. The way the log is written is, log has three parts to it. So you get log with the base, and then you have the level, and you have power. When we write a log of base 10, so we could write log of base 10, which is the base, and we could write 9 to power of 2. So that's one way of writing log. So you can see the 10 here is the base, 9 is the level, and 2 is the power. Now, when we write log in terms of the base, level, and power, we can then rewrite this expression as power log base and level. This is called using power law. So if I have log of base, say 10 of 1000 to x, I can rewrite that as x log of base 10, 1000. So that's the applying power law. You can see the power will then move to the front of the log here, and that will become power log base and level. So that's how you write log in the sense of how to apply it. Let's try a few things here in using that to transform log into exponential functions. So I'm going to write a log of y, or say log of a of y equals x. Let's assume the power is 1. So the power is 1 on y. So what we do is, if you're told to transform, or let's just do it this way. If you're told to transform or solve for this expression, so solve. So what we do is we go, well, let log of base a, y level y equals to x. Now what we now need to do is we need to raise a to the power of x, and that will be equal to y. So that's raise, and that will be equal to y. So the answer, we're transforming the logarithm into exponential function. So that will be a to the power of x equals y. You can see a to the power of x is an exponential function. In fact, y equals a to the power of x. So that's an exponential function. Now I'm going to transform the exponential function back into log, hence the inverse function between log and exponential functions. So if I have y equals a to the power of x, all I need to do is multiply both sides by log of base a, because the base of the exponential is a. So when I'm choosing my log, I have to use base a. So in this case, log of base a, y, will be equal to log of base a to the power of x. Now here we're going to use the power law to rewrite that expression, and that will become x log of base a of a. Now if we punch in log of base a of a into a calculator, such as log of base 2 of 2, we get 1. So what we're saying is log of anything and anything of level will become 1. So let's try that with this expression we're just dealing with. We already have y equals a to the power of x, and then we multiply both sides by log of a, base a. So log of base a of level y equals log of base a of a to the power of x. And then we change that into power law. So we said log of base a, y, equals x log of base a, a. We know what log of base a is. Log of a is 1. Therefore, log of a y equals x, 1 times x, which is x. So we can see now that x is equal to log of a y, just like we had in the first instance when we're trying to solve, when we're trying to transform back that expression into exponential function. Okay, so what have we got? So whenever we're given an expression, log of a, b, we need to equate it to x, and then we need to raise it to a to raise it to x, a to the power of x shall be equal to b. So that's how we transform that log into exponential function. So that will become a to the power of x equals b. And we can transform it back again into logarithm. So that will become, if we transform it back, so transform it into there, and then we transform it back into logarithm, that will become log of base a, b, be equal to x. And in order to do that, we need to multiply both sides by log of a, log of base a, and then from then we get the final answer here. So that's how we transform exponential function into log and log back into exponential function. Let's try with one example. If we're given log of 16 of level 8, we're told to solve. All we need to do is just equate it to x, and then we need to raise 16 to the power of x equals to 8. But 16 is 2 to the power of 4. And 8 is 2 to the power of 3. So we could rewrite this expression as 2 to the power of 4, that's the 16, to the power of x equals 2 to the power of 3. Now we multiply the powers, so that will be 2 to the power of 4x equals 2 to the power of 3. In this case, they'll both have the same base and equal to each other. So the powers will be equal. So therefore 4x equals 3. So that 4x will be equal to 3 because the base are equal. And therefore x equals 3 over 4. So that's the solution in that case. X equals 3 over 4. And that implies that, what that implies is log of base 16 of 8, level 8, will be equal to 3 over 4. So that's how to work with log and exponential function. Now let's try another example. Evaluate log 3 of 9. So now you're told to evaluate this. All you need to do is equate it to x. Log 3 base 3 of level 9 equal to x. Now, next thing we need to do is raise to the power of x, and the answer will be equal to 9. So that will become 3 to the power of x equals 9. So in this case, what we now need to do is to write 9 in terms of, so the clue is 3. We need to write 9 in terms of 3's. So 9 is 3 times 3, which equals 3 squared. And therefore, we can write 3 to the power of x equals 3 squared. And that implies that x equals 2. So that 2, x equals 2 because the base are the same. And therefore, the powers are equal. So x equals 2. So what that meant is log base of 3 of level 9 equals 2. Let's try another example. We need to evaluate log of base 10 of level 10. We're told to evaluate. So in this case, we need to equate that to x, and then we'll raise it, and that will be equal to that. So that will become log of base 10 of 10 equals x, which then becomes 10 to the power of x equals 10. So that's raised. That will be equal there. And therefore, this is 10 to the power of 1, by the way. Because the base is the same, x must be equal to 1. So the expression log of 10 equals 1. So that's a proof that log of a equals 1. Let's try another example. Evaluate log 0.001. Right. Remember that log of base 10 is also equal to log, which is also equal to LG. They all mean the same thing. So now we can write log of base 10, 0.001. But also we need to remember that 0.001 is 1 over 1000, which will become 1 over 10 to power 3. And if we can rewrite that, that will become 10 to power minus 3. So we can write log 10 to power minus 3, and then we can equate it to x. So we need to raise that, and that will become to that. So that's raised. So we're going to get (10 to the power of x) equals 10 to the power of minus 3. Therefore, x equals minus 3. As you can see, so LG 0.001 will becomes minus 3. If you punch that into your calculator, log of base 10, 0.001, you will get minus 3. Another example is we're told to evaluate ln e. Now we know what ln e is. Ln is log of base e. So if we write log of base e of e, and we know that that will become 1. Therefore, but we need to prove this, that it's 1. So what we need to do is not to jump to conclusion, just write x. Now, so what we need to now do is raise that to x, e to the power of x, and that will be equal to e. So that's e to the power of x equals e to the power of 1. Because they have equal base, their powers will be equal, and therefore x equals 1. Therefore, ln e equals 1. Here's another example to evaluate. Evaluate log of base 3, 1 over 81. Again, we need to say log of base 3, 1 over 81 equals x. We need to now raise 3 to the power of x equals 1 over 81. But 81 is 3 times 3 times 3 times 3, which gives 3 to the power of 4. So we can write 3 to the power of x equals 1 over 3 to the power of 4. And that becomes 3 to the power of minus 4. Therefore, 3 to the power of x equals 3 to the power of minus 4, which implies x equals minus 4. And so our question is log of base 3, 1 over 81 will be equal to minus 4. Right, we've got this question to solve. Solve the equation LGX equals 3. Well, remember, LG is LOG, which is also equal to LOG to base 10. So therefore, LOG to base 10 of x equals 3. In this case, we now need to raise. We don't need to equate it to x anymore. So we need to raise 10 to the power of 3, and that will become x. So therefore, 10 to the power of 3 equals x. Therefore, x equals 10 to the power of 3. So that's solving for x in this case. So we're using exponential functions here and log. Another question is, let's solve for log of base 2 of x equals 5. Again, we need 2 to the power 5 equals x. Therefore, x equals 32. So that's straightforward. Now let's try this question. Log of base 5 x equals minus 2. Well, in this case, it's especially just do the same thing again. You raise and equal to that. So that will be 5 to the power minus 2 equals x. And that is x equals to 5 to the power minus 2, which becomes 1 over 5 squared, which becomes 1 over 25. So x is 1 over 25.